transform is at the bottom here. You look at the bottom here, is there. So from here, after using the quadratic formula, I get the answer like this. 5 divided by s minus 0.549, s plus 1.215, I get like that. So you follow the formula at the bottom here, the bottom of the page, there is a Laplace table there. I just cut and paste in. Now there is a Laplace formula. Using this formula, you just go and put inside here. Actually, you reverse the order should be correct also, but the minus sign could be different. Either way should be correct, but I want it to be positive. I want the thing to be positive, so I do like that first. Minus 0.549, that will give me positive. If I put this one minus 0.459, I put it at the front. I think also can one, just that the sign is different. Either way will be, you will get full marks. Because sometimes you don't know which one you want to use. You put minus 0.549 to replace 1.215. You put at the front, also can one. I think your sign could be different. I haven't tried out, but I want it to be positive. That's how I do like this. I know that minus will give you positive. That's how I do like this. So the answer will be like this. Now, if we have problem, I don't know whether you got problem. For me, it's very straightforward. Now, if you got this imaginary, also same thing. Sometimes may not be so. I mean, sometimes question set can be very tricky. It may not give you 0.549 like that. No, it may not be 1.215. It could be J or I like that. 1.215 J or 1.215 I like that. Complex number. It's the same. You just put the J there. If you got J, then the alpha, all this will have J also. Alpha and beta will have J. You just follow everything, then it should work out. Yeah.
Is it the 5 is missing?
Yeah.
5? The 5.
Yeah. Yes, the 5 is missing. Yeah, I put it back for you, then I will upload for you. This one is not in the Google Classroom. I have to upload for you. Yeah, I have to upload for you also. Then I will change the part, the very crazy part, 72/36. That one. I change the part, then I update again. This one I will update. The 5 missing here. Yeah, right. So that is for the
inside the equation you given there also wrong. At the front part. I mean not here. Above.
At the top.
The equation that given in the question.
This one.
Go up a bit.
3.
Up
a bit.
Up a bit. The x1 up. The 5 the xi, the square is missing.
Oh yeah. Because I changed the question already. Yeah, I will update for you. I remove update 3 things update. Then I will post it in the Google Classroom. I try and get it done tonight. So tomorrow you can download from the Google Classroom there. Because I changed it on my paper. If I don't change, you won't be able to get the s squared there. I think you will get s cubed, isn't it? If I don't change, you will get s cubed. There's no solution for s cubed. Okay, now we go for this is for the first order. I mean, it's not actually first order. You got the s squared is second order. This was the second order calculation come in here because I just want to highlight because it never come up. This time will be important. This second order one. But all the time come up will be just how the 172/36. The one the college will ask how come all the time same format. So this time can be different. Just take note it can be this kind of SQ thing, is it? But make very sure you can get s squared. If you don't get s squared, that means something wrong with it. That means your calculation is wrong. because there's no solution for SQ1. You look at the table there, there's no solution. The solution in the second page, but these are too difficult. I won't go inside it. You will get SQ here, I notice. Yeah, you got S4 like that. But this is too difficult. So make sure you get S square. There's no SQ. I mean, after you simplify, the final equation is S squared. Cannot be S to the power of 4, S to the power of 3. No way you cannot solve. So after this one, now I go up to the other one, the second order. Second order will be like this. I'm not sure whether I have to go to this or I do the solution first or what. Now in your lab, some of you may not be doing it yet. In the lab, there are 3 types of oscillation, isn't it? Now second order will be like this. Second order, you got A d square x naught over dt square plus B dx naught over dt, C x naught and so on. You take Laplace transform. After you take Laplace transform, you can get the transfer function E over something something. So E over something something, the bottom part is called the characteristic equation. Everybody should know the transfer function, the bottom part of it is called the characteristic equation. So you look at the characteristic equation. Some of you doing the lab, you should know that. Now characteristic equation, AS squared plus BS plus C equals 0. When B squared less than 4AC, you will have under damping here. DC is damping coefficient. Damping coefficient equal to C1. Now, what is C1? C1 is for this particular curve. Then come to the critical damping. Critical damping, you got damping coefficient C2. C2 is a damping coefficient. For critical damping, you got B squared equal 4AC. And then for over damping, B squared greater than 4AC. B squared greater than 4AC is over damping. Damping coefficient for this curve is called C3. Then you look at this. Now you look at the critical damping coefficient C2. Look at the C2, that damping coefficient C2. That C2 you use for reference here. Zeta is no damping. Zeta equals 0 is no damping. Zeta equals C1 over C2 is under damping. Less than 1 is under damping. Zeta equals C2 over C2 equal to 1 is critical damping. Zeta equals C3 over C2 greater than 1 is over damping. But so far, there's no question set on this C1, C2. So, damping ratio, go back to the top there. Right hand side of the top screen. Damping ratio zeta equal damping coefficient DC divided by C2. I don't know why they use C2 for reference. C2 is the critical damping. Critical damping is C2. Damping coefficient C2. They use C2 for reference to get the less than 1, greater than 1. So the curve here, I think it came out 2018. Ask the student to draw the curve. The trade curve came out already. Last time came out already. So I cannot repeat because it's too close to 2018. If I repeat, they say, how come? How come all the time the same question, same format will be like that? Now look at the calculation there. Calculation is transfer function x naught over xi. So you got E from the top here. E over divided by A S squared plus BS plus C equal GS. I call it GS because in the MATLAB you use like that. So after you go and divide, we want coefficient 1 for S squared. The S squared has to be 1. Coefficient has to be 1. So we just divide everything by A. Top divide by A, bottom divide by A. We get the coefficient 1 for S squared. So you can copy over A 2 zeta omega n is B over A. Then E over A you can call it K omega n square, something like that. Up to you to call what level constant you want to call it. So for MATLAB use, K care is supposed to be a constant. For examination, care cannot be 1. Okay, for MATLAB, care always equal to 1. When you do your MATLAB lab, go to a lab, you do MATLAB, always take care to be 1 for root locus. I'm talking about root locus. Root locus, they use always care equal to 1. You will do root locus later on. So when you go to a lab, make sure when you see this kind of thing, how come care not there? How come care become 1? That is a rule for root locus. When you draw the root locus graph, all the while you have to use care equal to 1. But that's why I highlight here. For MATLAB use care missing, care become 1. If you in the exam, you want to get the answer calculation, care must be there. Care can be 2, can be anything. You don't let care go to 1. And then the bottom part is always used. Bottom part is the characteristic equation. Always use omega n squared. Just memorize it nowadays. Not difficult to memorize it. You will have to use it. Every year you have to use it. S squared plus 2 sigma omega n s plus omega n squared. You will have to use it every year. So you memorize this equation, then we'll do some of the calculation. Now the calculation is like this. All the calculation is based on, all this formula is based on, all this formula is based on what? Based on this kind of curve. This kind of curve is what? This kind of curve is, just how I say, is under damping, is it? Yeah. All the calculation, second order one, is based on under damping. Under damping, you got oscillation like that. You got overshoot. Overshoot is from here to here. Then you got transient. Transient is this curvy thing. This blue curve is called transient component. After that, the transient become horizontal line. You see the input here, the transient horizontal, isn't it? This is called the steady state component. Transient component is the up and down part. But after a long time, it will become horizontal line. The blue line is horizontal. That is the steady state component. So there are two components here. I think the transient is very fast, a millisecond or maybe 100 milliseconds, then it will stop. It will not go on forever, the curvy part. The horizontal part will go on forever, stabilize it. All the time is horizontal. After the curvy part, it will become horizontal. That is the steady state component. Now, you will find that there is a delta there. Now, before we come to delta, look at the rise time definition. Definition for rise time, TR is the rise time. Rise time, TR1 is never used, never come out in question. I don't think it will come out this time. Just look at TR there. TR is cut. The one is the maximum value. 1 is maximum value. 0.9 is less than maximum. 1 is maximum. So TR is cut the maximum here. That is the rise time. Peak time is the overshoot here. TP is peak time overshoot. Touch here, touch the top. Then the setting time is setting time. You have to see the percentage. 1.0 plus delta. It can be 1.2, 1.2% or 1.3%, 1.5%. That is setting time. You cut here. They will mention for you. TS is within 2% or within 3%, means plus and minus. Delta is plus and minus 0.2, something like that. 1.2, 1.2% or something like that. Then this one can be 1 minus, that means the percentage, the difference. So TS is a setting time, the percentage, the error here. So we got TR, TP, TS. All the calculation will be based on under damping. All your calculation. Now we look at the first example here. Now this kind of question is very easy. You should do it. Given system below, 5 peak time, setting time, maximum overshoot. Setting time 2%, setting time 5% error. 5% error means plus or minus 5%. You see the delta here. 1 is 100%, delta is a fraction of it. 1 is 100%. So plus and minus is the delta thing, minus delta, plus delta. That is the error, you see. So the setting time TS 5%, setting time TS 2%, it actually refers to the, we cut at 2%, cut at 5%, something like that. Now, when you see this thing, you quickly turn to just now the page I show you with all the formula. This one, I don't know where it is. Not this one, just now the one. I think it's this one. Yeah, it's here. You turn to the last page of your question paper. Last page of your question paper give you all the formula. That's why I said you don't go and memorize it. Everything is in the last page of your question paper. TP, peak time, omega n, pi, 1 minus theta square, like that. So maximum overshoot, everything is there. Now we look at this question here. Find peak time TP. TP is like that, isn't it? Now omega n, are we given omega n? We are not given, isn't it? Theta given or not? Theta not given. Now, so that in order to find peak time, you must know omega n, you must know theta, right? This is the formula, but they are not given in the question. So you have to look at the characteristic equation. Characteristic equation is 1 plus GS HS. GS is at the top. Now somebody say, how come there's no HS? There's no box there. No box means HS equal to 1. So remember, no box is HS equal to 1. Solid line means HS equal to 1. This is a negative feedback. Yeah, negative feedback. Now, when you come across feedback questions, first thing to look at is the summing junction. See whether it's negative feedback or positive feedback. This is negative feedback. So the next thing to do is to check, to get the characteristic equation. Characteristic equation is like this: 1 plus GSHS, which is the bottom half. You work out the transfer function CLTF equal GS over 1 plus GSHS. You will still come to the same formula like this. As I said, equation must put a 0 there. So you put in solid line means HS equal to 1. HS equal to 1. You do like that. This is the characteristic equation. Compare this characteristic equation with this one here. Very small. I enlarge for you first, otherwise cannot see. 150. Make it slightly bigger for you. Can see better. So after I zoom, you must compare with just how I asked you to memorize it. Memorize just how the second order one. Ask you the divide by A to get coefficient S square equal to 1. The one you have to memorize. You can memorize now. S square plus 2. Now this is the characteristic equation. For the, just go back for you. For just how I said here. I ask you to memorize it. This thing here, memorize it. You will have to use it. For this year, have to use it also. So you compare this one. Omega n square equals 16. 16, where got 16? 16 come from where? Come from this equation 1. Come from the characteristic equation. After you calculate from the diagram here, you can calculate the characteristic equation, isn't it? You calculate the characteristic equation, compare with the standard form here. Standard form is S squared plus 2 theta omega n S plus omega n squared. Compare with the standard form. You will find that omega n equal to 4. Omega n squared equals 16. Omega n equal 4. Then 2 theta omega n equal to 4 also. Why equal to 4? Look at this thing here. Look at 2 theta omega n S, the middle term here. Compare this middle term with the middle term of equation 1. Equal to 4, isn't it? So this one equal to 4. So you calculate theta will be, you know omega n equal 4, isn't it? So you can calculate theta. Theta is 0.5. Once you get these two variables. You get zeta and omega n, then you can get the TP. TP is peak time, is it? Peak time is 0.905 seconds. Now, this is how you calculate. Then the 2% error, now how to get error? How I know the error formula is like this? You don't worry, go back to just on the page I show you. Error formula for 2% is shortcut like this. Error formula shortcut 2% is like that. Now sometimes this is a shortcut. The answer is only approximate. You can only use the shortcut for 2%. Don't use 4 over zeta omega n for 5%. You can't use it for 5%. The shortcut 4 over zeta omega n is only for 2%. 2% error. TS, 2% error. You can't use it for 3%. Cannot. If you want it for use for 3%, the formula will be like this. Any percent today, any percent here. Now we are going to use 2% here. 2% will be shortcut will be like this. So 4 over 0.45 times 4. The setting time for 2% error is 2 seconds. 2% error means you have the plus or minus delta here. 1.2 is 100%. Delta is an error here. Plus delta minus delta. Delta can be 2% or 1%, something like that. The question says 2%, so you put in, use this formula, use a shortcut formula for 2% here. Then the question also asks you to find setting time 5%. You know that 5% you can't use a shortcut. Cannot use shortcut, you will do like this. Error formula is like this. Log. This is a natural log. Yeah, natural log. Use natural log. The e there, e to a power of something, right? Natural log. So put 5% here. Any percentage, you have to put in decimal. Don't go and put 5 there. 5 is wrong, is it? You never calculate any percentage using 5 or 2%. Use 0.05 or 0.02. That is the percentage in decimal point. So natural log 0.05 come out to be negative. Bottom minus zeta omega n is like that, 0.5 times 4. So your answer is still positive. That is correct. You will get negative second in your calculation is wrong. You can never get a negative for time today. Now the natural 0.05 is minus 2.997 per second. I put in here shortcut formula only for 2%. No shortcut for 5%. 3% also don't have, only for 2%. Maximum overshoot is this formula. Maximum overshoot is this formula. So you substitute for this zeta, substitute for pi, and substitute for zeta square. It's like that, 0.1698 or 18.98%. So this question will show you how to use all the formula given in the last page of the question paper. Error, just how I derive the log any percent actually come from the error here. The error percent actually come from this error, e to a power of something. But usually you don't want to waste time to take log on both sides. Too long to do it. Take log on both sides. I mean, take too long.